Good morning, everyone. Welcome to our second training in the swamp bioaccumulation monitoring training series. My name is Anna Holder. It's not on this slide. I am the program coordinator for the statewide swamp bioaccumulation monitoring program. And I delivered the first training that we held back in January, which feels like a long time ago. Just a heads up, we're recording this meeting so that we can post the lecture components after the fact for those that weren't able to join us today or miss parts or you want to go back and visit. But we really encourage y'all to ask questions throughout, chime in. If at any point you want to contribute but don't want to be recorded, you can either ask us to pause the recording at that time and we can pause it then and there. Or we can, you can let me know which parts and I can cut that part of the recording and it won't be posted after the fact. Whatever feels most comfortable for you, we will do that. And at the very end of the training, before we close, we'll ask if folks want to have anything cut or anything like that so that I know what to do when we prepare the final post to share. So with that, I'm so excited to hear the details of today's training, and I'm going to pass it off to our trainers for today. Jay, if you want to give a wave, they're going to do a bigger introduction. Tessa and Wes. Take it away, y'all.
Thanks, Anna. Welcome, everybody. We're excited to do this training today. Quick overview of the agenda. We're going to start with just some introductions and reviewing the agenda and goals. Then I'm going to have a longer part of the agenda to talk about general planning and design. Wes Smith is going to talk about informing fish advisories. Tessa Foget will talk about data quality and data management. We are going to fit a break in there because it's kind of a long training with a lot of information we're going to be providing. Then at the end, we're going to have some more interactive topics. We want to work through a couple of examples. We have examples, and we'd be happy to talk about examples that you want to bring up for us to consider as potential water bodies to monitor. We'll have time for questions and discussion, and then we'll wrap up at around noon. So we want to start by just having introductions and hearing from you all. I would like to quickly go through and just have everybody test their mics and their cameras, and have you introduce yourselves. We'll skip the trainers because you'll hear more about us. And I'll just call you out and then say your name, your affiliation, and where you're calling in from. So if I'm just going to go in order of as I see people on my screen. So of course the first name I'm not sure how to pronounce, but Spag Dowd.
That would be Spaggy Dowd. Thank you. Hello, and glad to be here. My name is Spaggy Dowd with Resigini Rancheria of Yurok people in Klamath, California. Thank you for having me.
Excellent. Sherry.
Hey everyone, my name is Sherry Norris. I'm with the California Indian Environmental Alliance, wishing you all a good morning. Good to see some familiar faces in there. Thank you, trainers, for coming on today.
Thanks, Sherry. Aaron?
Good morning, guys. Aaron Brazonovich, Environmental Coordinator for Susanville Indian Rancheria. Welcome.
Excellent. Zachary?
Hey, good morning, everyone. I'm Zach Chagone. I'm an environmental scientist with the Shingle Springs Band of Miwok Indians in Shingle Springs, California.
Great. Megan?
Good morning. My name is Megan Poffenbarger. I work for the Pechanga Band of Indians in Southern California in Temecula.
Great. Javier?
Hello, my name is Javier Silva, Jr. I am the climate/environmental educator here at Red River Valley Rancheria.
Yeah, good thing you put junior in there. So I'm Javier Silva, senior. That is my son. I am a Sherwood Valley Band of Pomo member. I am of Noyo and Yokeo descent, and I am calling in, zooming in from the homelands. I'm at the mouth of the Noyo River, also our village site, in the Cadieux. So welcome, thank you.
Thanks for jumping in. I was just getting confused about the two Javiers.
Yeah, good thing we both have cameras on, I guess.
Yeah. Jessica.
Morning, everyone. My name is Jessica Gravel, and I'm the Marine and Climate Resiliency Program Manager for Trinidad Rancheria in Humboldt County.
Thank you. Autumn.
Hi, my name is Autumn Bonema. I work at Moss Landing Marine Labs in Moss Landing, California, and I work with our presenters on the statewide program.
Brianda.
Hi, everyone. My name is Brianda Hernandez. I am the Water Quality Program Coordinator for the Bishop Paiute Tribe out in Bishop, California. I'm excited for this training. Thank you.
Thank you. John. Oberholzer.
Yeah, my name is John Oberholzer Dent. I'm a biologist with the Karuk tribe up in Happy Camp.
Daniela.
Good morning, everyone. I'm Daniela Santana. I'm the environmental director for the Hubba-Mintel Pummelbuck Lake.
Coach Jackson.
Good morning, everyone. I work with Indigenous youth out at the Rincon Reservation.
John Wright.
Hi, I'm the environmental specialist for the Rincon Reservation.
Christina.
Hi, I'm Christina. I am an environmental scientist with the Washoe Environmental Protection Department in Gardnerville, Nevada.
Bradford. You're on mute, Bradford. Oh, here we go.
Sorry about that. Bradford Norman, Wetlands Program Coordinator, Resigini Rancheria. I'm zooming in from Klamath, California.
Great. Sophia.
Hello, my name is Sofia Bejarano. I am the environmental coordinator for the husband of Kumeyaay Indians from San Diego.
Great. Monica.
Hi, sorry, I'm at home sick, so I'm not going to turn my camera on. I'm going to spare you guys. But my name is Monica Heiner, and I'm the Environmental Division Manager for the Tolowa Dene Nation up here in the Smith River.
Great. And Mike.
Can you hear me? I was trying to unmute.
Yeah.
Okay. Good morning, the Water Resource Manager with Potter Valley Tribe. Looking forward to the training today. Thank you.
Great. I think that's everybody. What a great group from all over California. This is very cool. Okay, now we want to learn even more about you through some polls. So I'm going to turn this over to Anna.
Yeah, so I just launched the poll. There are 5 questions. Some are multiple choice, some are you can provide a short answer. Kind of give us your gut reactions, what comes to mind first. We'll leave this open for a couple of minutes, and then we'll share the responses. I launched the poll. Are people able to see it on their screen? Okay, great. And I made all of the long or the short answers required, but if you don't feel comfortable sharing that information, just write like NA or hard pass or so just put something in there so that you can submit.
You can write an essay with those questions.
And if I don't take the poll, should I close it, or how will the results come up?
I am going to end the poll and then share the results, and
Got
the
it.
results should be shown on everyone's individual screens, but not in the recording, I learned last time, which is, I think, okay.
Can we save it somehow? Maybe
Yes.
just screenshots or something?
Yeah. So we've got over 50% of folks have submitted, and that number is climbing. Okay.
Hello, can anybody hear me?
Yeah.
Yes.
Hey, my name is Speed. I was Resident Rancheria, and I'm trying to submit mine, but it's not. I just hit submit, and it's not doing anything.
Were you able to put something into even all of the boxes? Like the
No,
long.
actually, it said there was like five questions or something. I think I only got the first three, but I couldn't get to the next or any more questions, and I tried to just hit submit to move on, but it wouldn't. It just wouldn't do nothing.
Oh, I'm sorry about that. If it's not working for you, I apologize for that. And feel free to chime in if you want to, if you see the results and you're like, I think differently about that, or +1, whatever.
Okay, no problem. Just wanted to make sure I was.
Are you able to, does it like scroll down at all? Are you able to?
Well, at this point now, I pushed close the poll, so I can't.
Yeah, it's passed.
Yeah, no worries.
I had to close the poll to be able to speak, so.
I think two of the key questions, Spaggy, is are there species of concern that you want to monitor for, and are there any what kind of locations are you wanting to monitor in? Maybe if you put them in the chat, then these guys can know and make sure they hit those points.
Okay.
And I think we've got most of the folks that aren't trainers that have participated, except for Spooky, unfortunately. Again, apologies. So I'm going to end the poll and share the results. Ooh. So Jay read my mind. So can y'all see the results on your screen? They're popping up for you in that box?
Yes.
Yes.
I'm not sure what I should hit.
Like, nothing.
Okay.
For the question on what species are you interested in monitoring, it says 100% answer and it gives you our answer, but it doesn't tell you what other people said. So if you guys can see it, you might want to share that.
Yeah, let me try logging in to that.
But otherwise, level of experience, it looks like 50% are brand new.
Yeah.
38 are some experience pretty new, and 13 is several years. And then again, what species are you interested in? That's the other one that doesn't show. So that might be interesting. 81% is looking at mercury and selenium. And then the next highest is PFAS. Then it goes into industrial chemicals at 56. Oh, I'm sorry. It goes into pesticides, then industrial chemicals, and then others not listed. So that's interesting.
I'm going to stop sharing the poll, and then I was able to pull up the results. So I'll need to share my screen.
All right, I'll stop sharing.
Cool. Good on Zoom for making it just a little bit too complicated, more than it should be. Okay, let's share that. And I'll zoom in. Okay, so folks are interested in bioaccumulation for lots of reasons through the work that they're doing for their job, community safety, teach Indigenous youth to be a better steward, environmental programs, love it. Aha, there's a scroll. Stream health, to understand contaminants, yeah. So we got the level of experience. It's a nice combo, which is great. So that means we can all teach and learn from each other. Mussels, in terms of species, inverts, kelp, seagrass, steelhead, traditional fish and plants, unsure, also love those answers. Great. All the things. That's a common desire for us too. Yeah, we went over the contaminants.
Well, you said to
again.
keep it short. You know, we had to keep it short, so you know.
All the things. That's yeah. It's short and sweet for sure. So water bodies, got some coastal wetlands, large rivers, creeks and ponds, tributaries, interest in partnership, great. And then all the things. I love it. I think that's my favorite answer. So I'll stop sharing and pass it back to Jay.
Well, great. It's very, very helpful, a little bit surprising. It's good to know that we'll pitch things at the sort of simple level for the beginners, but I think there's a lot of things of interest for the more experienced folks as well, because we're trying to capture a lot of our pretty extensive experience in what we're sharing with you all today. I'm going to start sharing again. Get back to the right place. Uh-oh.
It's the first one on that list.
Oh, yeah. Jeez. I've got too many windows that you can see. All right, so I'm going to skip quick over this one because we're each going to introduce ourselves in some more detail. So I'm Jay Davis. I'm with the San Francisco Estuary Institute, where I've worked for a long time. I've also been the lead scientist for California's statewide bioaccumulation monitoring since 2006. This is done by the Surface Water Ambient Monitoring Program, or SWAMP. That's an acronym that we'll be using in the slides later because it's way too long to spell out all the time. I have other experience. I've been working on fish monitoring since the 90s. I really got started with fish monitoring in San Francisco Bay through my work with the San Francisco Bay Regional Monitoring Program. And that led to some work in the Sacramento River watershed and the Delta. And got some projects going currently that have kind of helped me think through what to share with you today. We're gearing up for our latest round of sampling on the bay. We do this once every 5 years, so we're getting everything set up for that. And then we have another I have another project with a community organization in San Francisco Bay, where we're just completing the sampling and getting ready for the next phase of lab analysis. Some background on me: I have a PhD in ecology from UC Davis, where I studied bioaccumulation in double-crested cormorants on San Francisco Bay. I grew up in Illinois, and I currently live in Half Moon Bay. That's where the photo is. Me and my home habitat, which is on the unceded ancestral lands of the Ramaytush Ohlone. So over to Wes.
Thanks, Jay, and want to thank everyone for joining today. Really look forward to working with everyone. My name's Wes Smith. I'm a senior toxicologist at OWIHA, and I've been at OWIHA for about 12 years. I started out doing drinking water contaminants and then moved into fish advisories. And then shortly after that, started working on seafood safety after oil spills, and I've been doing that for about 6 years. And when I'm not responding, working on microplastics and other contaminants of emerging concern. And recently, I took the role as the chief of the Fish Ecotoxicology and Water Section, we're the lead state agency for fish advisories. We do some work with harmful algal blooms and also oversee seafood safety after oil spill. And then I did my doctorate in the University of Montana in pharmacology and toxicology. I grew up on the other coast in Massachusetts, and I currently live in Sacramento, which is the unceded ancestral lands of the Nisenan, the Southern Maidu, and Miwok tribal communities. And look forward to working with everyone. Thank you.
Hi, everyone. I'm Tessa Foget, and I work at the State Water Board, and I work in our surface water ambient monitoring program with Anna, and which we call SWAMP, and I'm our quality assurance officer and database manager for that program. I've been with the water boards for 12 years, and I've done kind of a variety of things with surface water monitoring, focus on pesticides and also contaminants of emerging concern. I have a degree in environmental chemistry from UC Davis. I grew up in Wisconsin. I currently live in Davis, which is unceded ancestral lands of Patwin and Miwok. Thank you.
Great. So that's it for the introductions. We do want this to be interactive today, so we encourage you to ask questions as we go. And then we've got a good amount of time for discussion and question and answer at the end. But the schedule's pretty flexible, so don't hesitate to ask questions as we go. So we're going to start with me with a relatively long block talking about all the different aspects of general planning and design, or how to design a bioaccumulation monitoring project in 18 easy steps. And there's a bit of facetiousness in there. A lot of these steps are not that easy. And even an hour is not really, it's not really easy to cover all these items in just 1 hour. But it was helpful to me to think through this training and lay out all these steps. And as I said, going through a couple of projects that are actively going through all of these steps in the last year and currently has been helpful in me coming up with what I think is a pretty inclusive list. A lot of what I'm going to show is also really informed by what we do in the SWAMP program for the statewide monitoring. So this slide, I think, will be a handy reference, and we're going to go through each of these items one by one. So some key resources. There are a lot of documents out there that are helpful guidance, but these are three key ones. First, there's a US EPA guidance document that's kind of the Bible for guidance for bioaccumulation monitoring. And for this presentation, I haven't looked at it for a while, but I've been using this since the early 2000s, since it came out, and it has not been updated, but it's I think that's not really a bad thing, because it's got a lot of great information in it, and the basic principles of monitoring to support advisories hasn't changed much in that time. So that's a great document. Very thorough treatments of all the different aspects of fish monitoring to support fish advisories. Another key document is from California that Wes is going to share some information from, and that's from his Office of Environmental Health Hazard Assessment, a protocol document for fish sampling and analysis to support development of advisories in California. So very relevant. And then I have an example of one of the documents that the SWAMP program has produced over the years. This is one of the monitoring plans, the sampling and analysis plan for our monitoring of bass lakes. That this document was published in 2015, but we've published a series of these documents over the years. This is just one example, but a lot of the steps all the steps are laid out in these documents, from defining what questions you're trying to answer through through all the steps of the monitoring program. So those are also very, very helpful documents. And I see something in the chat, but I'm not going to look. Just let me know if anything comes up that I should know about.
Yep, you're good. Keep on going.
Okay, so step one, obtain funding and align partners. So key ingredient to monitoring is resources. Some of this can be cash, some of it can be your own time or in-kind contributions of services, but bioaccumulation monitoring is expensive, especially when you want to analyze organic chemicals like PFAS or PCBs. These analyses are quite expensive, and it takes a lot of effort to collect samples and to collect them in a way that doesn't compromise the analysis that you're going to do. You need to make sure that there's no contamination along the way. So a lot of labor goes into collecting samples, and then also basically that's why the analysis is expensive, is that it's very labor intensive. So one form of resources is doing it yourself, and there are a lot of parts of this that you can do yourself. The planning, the laying out the sampling plans, collecting the fish or the species that you want to analyze, and then doing the data management and reporting. But usually you're gonna, unless you work with an organization that has a lab that can do this type of work, you're gonna need to find a lab, ideally a lab that has clean facilities, that is experienced with processing samples. Autumn Bonema, who's on the call, is the wizard of this for the SWAMP program and for the regional monitoring program as well. It's a big job, that part of it, and then the analysis. The chemical analyses are specialized, and in general, you're going to need to hire labs, and that usually requires cash. So there's likely going to be the need for some direct cash funding, and I haven't done a lot of work with tribes or tribal governments, so I'm not that familiar with funding sources available to tribes, but often obtaining the funding entails writing a proposal to get funding. But in some way you will need some funding for the work. You can line up in-kind contributions. One kind of extreme example of this is in Southern California. The Southern California BITE has a monitoring program that's been going for a long time. And it's a consortium of wastewater agencies that have labs so that they can do that whole program, almost the whole program with in-kind contributions. But that's kind of a special case where it's a group of agencies with labs. But there can be in-kind contributions for the sample collection for different aspects of the monitoring. But again, it's likely that you will need some funds, especially for the lab work. So no small feat getting the funding, but it's essential. Another step that is important is establishing an oversight plan and monitoring. I can't think of monitoring that's going to be done in a vacuum. There's always going to be the goal to inform a community and to generate high quality information, or maybe to inform a regulatory process. So oversight's needed to ensure both the impact and the quality of the work. And the impact means having the community engaged that you want to communicate to. It's good to have that engagement at the from the beginning to the end of the project, to know what the community information needs are, and then to communicate the information back out to the community. The groups that are likely to be involved would be your organization. You might have a stakeholder or community or tribal group or group of tribes that that would be interested in your work and that you would like to report out to. If there's a funding organization, then it's good to include them, or they're part of your oversight plan. And then an important part is, we do a lot of this in the larger programs. We bring in outside experts to provide peer review, but even if you're thinking of a small project, it's good to consult with experts along the way to help you with your design, with identifying labs, with interpreting the results. So it's important to be able to consult with experts. We're doing this training today, but I think I can speak for all of us that we're willing to provide advice for your monitoring as you go forward. That's part of the purpose of the Safe to Eat work group that Anna and I co-lead, coordinating and supporting bioaccumulation monitoring throughout the state. So we're available to provide advice, but in some cases you may want to bring in your own experts, or some of you are experts. Maybe you bring in some of the experts that you know, but it's most important to get this kind of expert input in the early stage of your monitoring, in the design stage, because that's the critical point where you sort of head down the right path or not. And if you don't head down the right path, then you can end up wasting precious resources. In the sort of scientific field, we go through this process of getting journal articles peer reviewed, but that kind of peer review at the end of a project, helps you refine your analysis of the data and how you report it, but the work's already done. You've already gone down a path, and you may not have gone down the perfect path to answer the questions that you've set out to answer. So getting this type of expert help in the early stages is really critical. Okay, step 3 is identifying the goals and questions that you want to answer. And this is sometimes the hardest thing to do in a monitoring program or project. Sometimes if you're trying to support management actions, it means that you need to know what management actions you're going to take. So you need to figure out figure out the management side of things in order to design a good monitoring program, which is hard to do. So it's sometimes very difficult, but it's always a crucial step in designing a monitoring effort and setting yourself up for success, because success will be defined by whether you answer the questions that you set out to answer. Different goals or questions call for different designs. One of the typical goals that that bioaccumulation monitoring programs have, or particularly sport fish monitoring, is to get an advisory in place for a water body or to get more species on the advisory. So that's why I'm showing an advisory here, and we'll talk a lot about what's needed to support an advisory. That's a common goal, though. Another common goal in our statewide monitoring is to support water quality regulation, which a key step in that is determining whether a water body is impaired or not, if the water quality objectives for the water body are exceeded, and that leads to the designation of a water body as being impaired by whatever contaminant is exceeding the objective. And that's a key step in the regulatory process, and initiating the need for a cleanup plan. So that's often a goal, is in something that we've done a lot of in Swamp. We've supported the listings of hundreds of lakes throughout the state with our fish monitoring, particularly for mercury. Another type of goal is to inform management efforts, either guiding new ones or the effect of past ones. And sometimes there are intentional efforts to clean up contaminated sites around a lake, like mine sites. Sometimes aerators are installed to try to reduce methyl mercury accumulation in the food web, and there's a need for monitoring to know if that type of action works. Sometimes there are actions that aren't really directly aimed at water quality, but can affect water quality, like reservoirs get emptied and then refilled, or fish management can affect mercury concentrations. So another type of set of questions that can be tracked with bioaccumulation monitoring is the effect of these management actions on accumulation in a water body. So as an example, swamp, I'll go through some of the swamp's questions that swamp's trying to answer, and there's a set of general questions, which are the questions that big monitoring programs tend to answer. The status of water quality in a water body or set of water bodies. What are the current levels of contamination, and are water quality objectives being met or not? Is there a need for fish advisory? Is another form of a status question. Trends. What is the rate of change over time? Are things getting better or worse? Is a common question. Problem identification. Which water bodies have problems, or which parts of a water body have problems? Diagnostic, what's causing the water quality problems? What are the sources of the contamination? And then evaluation is aimed at the management actions and whether they're effective in cleaning up the contamination in a water body, or are actions making things worse? So those are very general questions, but when we design our efforts, within a year or more specific monitoring, like our lakes monitoring, we come up with more specific questions. So as an example, when we did a round of lake sampling in 2016, where we were sampling some new lakes that hadn't been sampled yet, and then some lakes where there were data gaps. So for the new lakes, the questions were, these are more specific and more directly answerable. Should a specific lake be considered impaired and placed on the 303D list? The second question was, should additional sampling of bioaccumulation be conducted to support consumption guidelines? Because the basic design we use for a new lake doesn't usually generate enough data for an advisory or enough species, cover enough species, and Wes will explain that in detail later. So this question is, do the current levels of contamination suggest that we need advice in this water body and should do additional sampling? And then another set of lakes in this year's monitoring were clean lakes. We went through an effort to try to identify lakes with lower levels of contamination in California. Clean is kind of a challenging term. They're not totally clean. No lake in California is totally clean, but cleaner. We call them clean lakes for short. But the question there was, which popular lakes in California can be confirmed to have relatively low concentrations of contaminants in sport fish? So these are examples of more specific questions that that when you conduct a study, you can call it a success if you answer these questions. Okay, so you've got your questions. A key step early on is knowing what existing information are out there and reviewing the information that's out there. SWAMP has generated a lot of data across the state and is a great reference data set. We'll go into that in a little bit, but there are potentially other sources of data that don't make it into the statewide data set. That maybe there's local data, but it's important to find all the data that exists, so that you can make the best use of the funds that or the resources that you do have. So look at the data that exists, and then determine what the gaps are. What additional data are needed? Maybe there are some data, but there are more species that you'd like to look at. Maybe you didn't look at the species that accumulate the most, or the species that might be cleaner. Maybe you want to look at, our presentation today is very fish oriented because that's what we've been focusing on in SWAMP, but maybe you want to look at plants, maybe you want to look at shellfish, maybe you're concerned about wildlife and you want to look at wildlife. So there are lots of potential topics in under the bioaccumulation umbrella. Gaps in relation to advisory development is usually a key question. And then you can also look at what data exists for nearby water bodies. So that can kind of help you know what to look for in the water body that you're interested in. So SWAMP has generated a great statewide data set and continues to monitor and may have already addressed some of your data needs. The program's been going since 2007, and we've sampled hundreds of water bodies. So either your water body or a nearby water body has probably been sampled by SWAMP, and it's a great high quality reference data set to compare your data to. it's I recommend keeping track of what we're doing in the bioaccumulation monitoring program, and under the guidance of the safety work group, because there might be opportunities to either piggyback on the work that we're doing. This is something that the water boards do a lot of. The regional boards piggyback on the state program and add to the list of things that are being analyzed. There might be ways to piggyback on the sampling that's being done, or the samples that have been collected. And so that, actually kind of piggybacking on the work, but then also there's definite opportunities to influence the monitoring that SWAMP is doing. And if you're tracking the process, and let SWAMP and the STU know what your bioaccumulation monitoring needs are, SWAMP might do some of the monitoring that you want to have done. And there are a couple of, Anna talked about these efforts in the first training, but we have a realignment effort that is working through the water board regions of the state and doing community guided monitoring. We started in San Diego, and we're going to be monitoring in the San Francisco Bay region. Next year will be the monitoring, and we're doing the planning work this year. So realignment is an opportunity to influence what's being monitored by SWAMP. And then right now SWAMP's also undergoing a long-term priorities assessment, gathering input from the water board regions, but also tribes and community groups on what the statewide program should be monitoring going forward. So I definitely recommend bringing your monitoring needs to SWAMP, and they might actually be covered one way or another. Okay, I want to quickly introduce you to the statewide data set that I mentioned, and this is a graphic from a website called the Safe to Eat portal that is part of the My Water Quality website of the California Water Quality Monitoring Council. And the state is continuing to develop ways of accessing the bioaccumulation monitoring data statewide, and developing new tools. This is a tool that was developed a while back, but it's available, and very usable now. So I'm going to show this. Stay tuned for further developments on ways to access statewide bioaccumulation data. But this is a screenshot from the Safe to Eat portal showing all the locations that have been monitored up through 2017 by SWAMP, and then it also includes some other data sets. So hundreds of lakes, and close to 100 river locations, and about 70 coastal locations have been monitored. Each of these symbols is a monitoring location. Sherry.
Oh, it looks like you're muted, Sherry.
Oh, sorry. If you want to put a link, or we can put is it the mywaterquality.ca.gov?
Yeah, that's how you get to the My Water Quality website.
Do you want to later put a link in? I just want to tell people I've used this a lot. It's really helpful. Does it still have it that allows you to sort by nearby water bodies?
Yeah, I'm going to show a quick demo of it right now.
Oh, yeah.
And then
guys, so when they put the link in, head to this and really check it out. It's really helpful.
Is it just me, or is Sherry's audio a little choppy? So
It's a
let me
little
know.
choppy, but
Okay.
I heard enough to know
Yeah.
that she wanted the link added to the chat. So it
Yeah.
has been added.
Great. So we are going to play around with this a little bit now, and then also we'll use it later when we talk about examples. So the slides are going to be made available and have links, so that the link will be in the slides in addition to being in the chat. So I mentioned these bullet points, and then there's some links from the first training session with more discussion about accessing data. But for now, I'm gonna.
And while G's pulling the safety portal up, we've gone through the first 4 steps of 18, which is a lot, and we've got about I'm gonna say like less than 20 minutes left of the originally allocated hour. Do folks have questions or anything coming to mind for them thus far?
We did start a little. We did go long on the first item, so
yeah.
I want to go a little longer, or not. Stick to the 60 minutes, but thanks. Thanks for the reminder on the time. Okay, so just a quick demo of this. We can go through it in more stepwise fashion later if there's time, but for now, if you click next on this homepage, then it walks you through steps to select what you're interested in. I'm going to skip the instructions and just go to the map. And so this shows that same data set. It shows every location that's been sampled, but this initial screen is set to show, it shows filled in symbols where we've collected largemouth bass, which is the species that we've looked at the most. So I'm going to pick, you can click on any of these water bodies and it shows the data that are available, all the species that have been sampled and different years. So this East Park Reservoir was sampled before swamp in 2006. There was monitoring done there, and then swamp started in 2007. Sampled carp and largemouth bass, which is typical of what swamp's been doing for the statewide monitoring. And then there was more monitoring done in 2012. There's a lot of handy features on this tool. It shows you can look at different contaminants. Right now, it's just showing all the mercury data. You can see a graph of the data over time for all the different species. What Sherry mentioned is it shows data for nearby water bodies. So I think this is a useful feature if you're looking at designing monitoring for a water body. You can see what's been found nearby in the region. It shows the distance to the nearest water bodies and the data. You can also print a report that has that same kind of information and shows a map of where the other locations are and the data for the other locations in more detail. And then another important thing to know about your water body, if you're starting monitoring and you're interested in advisories, is what is the advice for that water body, so you can view the safe feeding guidelines. There, so for this reservoir, there is a specific advisory for this water body. If there's not a specific advisory, the portal shows the statewide advice for the general advice for lakes. So this is a very useful tool for knowing A, if there's data for your water body, and then B, what's been monitored in the region. So we're going to play around with that more later this morning. All right, back to the show. Okay, so step 5 is considering designs for the type of water body that you have. And the designs are different for lakes and reservoirs, rivers and streams, and the coast. One key variable for lakes is the tremendous range in size. And for swamp, we've developed size categories, and OEHA uses these as well. Small lakes, less than 500 hectares, then going up to medium, large, and very large. I'm going to show some examples. So this is an example of a representative small lake, Lake Piru in Ventura County. This is 484 hectares. The diameter of this circle is 1 mile, and it's the same for the next 3 maps that I'm going to show for larger lakes. So for a small lake, one sample location is considered to be representative enough of the lake as a whole. So we sample, for small lakes, we sample one location. And swamp does their sampling, our sampling with electroshocking boats, and they work within a half-mile radius, within a mile diameter circle. So, that's what we define as one sampling location. They need to be able to move around that much to find enough fish. And so for a lake that's this size, 1 mile is more than the width of the lake and almost, about the length of the lake. So this one location provides pretty good coverage of the lake as a whole. So we do one location for lakes of this size. For medium lakes, this one is 884 hectares, Pardee Reservoir. The lake's 4 miles long. So for a lake of this size, we do 2 locations, and there can be differences in concentrations from, over this distance. The largemouth bass that we sample tend to have small enough home ranges that you could see differences in from this side of the lake versus this side. And then we also monitor prey fish, which also have home ranges that let you see differences among locations like this. So as the lakes get bigger, we go first to two locations. For a large lake, in the large category, between 1,000 and 5,000 hectares, we usually do 3 locations. And this sometimes varies, but that's kind of the standard. And you can see that, when the lakes are getting this large, you need more locations to provide coverage. And then for a very large lake, like Lake Berryessa, we've done 4 locations. And, again, these circles are all 1 mile, so it's quite a distance from the north end of the lake to the south end. And, there are different arms. In some lakes, there are different sources of contamination in different parts of the lake. So it can be really valuable and necessary to sample more than one location. If you just sample one location in this lake, you could easily miss something important. River stations, different scenario, obviously. Wes is going to talk about the numbers of stations per mile, but we use the same kind of concept with a half-mile sampling radius around the location that, the designated location. So this is the American River near Discovery Park, and showing we go up and down the river here to get the number of fish that we need. So it's not just one point. It is necessary to be able to move around to find the fish and get the numbers that are needed. And then on the coast, SWAMP has established about 70 coastal zones where we've basically divided up the coast into these units based on fishing, the amount of fishing activity and fishing piers, but covering the whole coast. And within each zone, we try to hit the spots where people fish the most, but there's flexibility to move around within a zone like Tamales Bay here. So different designs for different locations. Okay, selecting contaminants. Obviously a key step. We saw the list of contaminants of interest to the group early on: mercury, PCBs, selenium. More folks said organochlorine pesticides than I expected, and then PFAS is a newer contaminant. It's classified as an contaminant of emerging concern, although I think they have emerged, but they're not as far along in the regulatory process or in the advisory development process as the other contaminants, but definitely a lot of high interest in California and across the nation. But obviously there's a lot of design implications for these different chemicals that we'll go into. And there are different analytical techniques, to different sampling designs and different analytical techniques for these different chemicals. Another contaminant of more recent concern is microplastics, and there's growing interest in the occurrence of microplastics in the environment, and that has a lot of design implications if you want to try to look at microplastics. Then there are other contaminants of concern in other species. In addition to the list for the fish, there's in bivalves, there are contaminants that fish metabolize, so they don't reach high levels in fish, but they can reach levels of concern more commonly in bivalves, like algal toxins. San Francisco Bay is a good example where we frequently see levels of microcystin and saxitoxin in mussels in the bay that are above levels of concern. PAHs can sometimes be at levels of concern in bivalves, especially after spills. They accumulate more in bivalves because the bivalves don't metabolize them like the fish do. So contaminant selection is clearly a key step. Selecting species ties in with the list of contaminants that you want to analyze. So a lot of considerations go into what species to sample. Obviously, you want to sample the species that are popular for consumption, and if there's a need to fill a data gap for consumption advice, then that's a priority. Certain species are indicators for contaminants of interest. I'll talk about the examples of that. One important design tip is that it's good to have a long list of species. If you're sampling a water body that's got a diversity of species present, this is very common on the coast, but also in some lakes. You often don't get exactly what you plan to get. So it's good to have primary target species and secondary target species. You need to have a plan B or a plan C in case that whatever species you're targeting is hard to get or not present. Another factor is considering what's been sampled before and repeating the same species so that you can look at trends. So we, in our presentation today, we're focusing on fish and sport fish that humans eat, but other species can be useful for monitoring management actions, wildlife impacts, or other purposes. Swamp has done some wildlife monitoring in 2012 and 13. We did a statewide survey of mercury in grebes on lakes and found levels of concern in a lot of the lakes, similar to the concern for human health. So wildlife impacts are also possible and potential topics of study. And then again, we're focusing on fish, and we've done the most work on fish, but other non-fish species may also be of interest, like shellfish, plants, or wildlife. So different contaminants kind of call for different species. We've done a lot of work throughout the state with black bass, and they're really excellent mercury indicators. Mercury accumulates in muscle tissue, and the concentrations are higher in larger, older predator fish. So the bass that are relatively large and long-lived and at the top of the food chain have high levels of mercury. They have a tie to human exposure. They accumulate very high levels relative to other species. They're very widely distributed, as I showed in that map earlier. They integrate over time and space, but are still very responsive. And they generate highly reproducible data if you collect them the right way. But since the concentrations are higher in the larger, older fish, you really need to take that into account when you're doing your monitoring. Because if you don't, then the data have a lot of unwanted noise in them. So it's best to collect fish spanning a wide size range. And if you do that, then the largemouth bass or black bass are a great litmus test for mercury contamination. Prey fish are also valuable mercury indicators, like the bluegill shown here. Swamp has been doing prey fish monitoring for many years and collected a lot of bluegill for this. Prey fish have a connection to both human and wildlife exposure. They're also good accumulators, widely distributed. And one advantage is that there are a lot of lakes in California where trout are present and bass are not present, especially at high elevations. And in a lot of cases, the trout are hatchery trout that are planted. And in that situation, they don't really indicate what's in the food chain in the lake because they haven't spent enough of their life there. But in that scenario, the prey fish can be a good indicator of what's actually going on in the food chain. It's still valuable to know what's in the trout because that's what humans are eating, but it doesn't tell you what the level of mercury in the actual ecological food chain is. So prey fish are valuable in that scenario. They also are short-lived and respond in shorter timescales, so they're very good for monitoring management actions and like getting seasonal information. But the data are noisier than for black bass. For PCBs and organochlorine pesticides and dioxins, a different approach is best, where you look at species that have relatively high fat content, lipid is another term for the fat content. These chemicals accumulate in the lipid, and these bottom feeders have relatively high lipid in their muscle tissue, and in their bodies in general. So they are stronger accumulators of PCBs and DDTs. And in addition, they're bottom feeders, so they might be more exposed to contaminants because of that. So species like carp, catfish, bullhead, and sucker are good indicators for this type of pollutant. For PFAS, we don't have as much data. I haven't done a thorough literature review, but in the reports I've looked at, it seems like that they kind of accumulate across species. They have a different mechanism for accumulation. They accumulate in cell membranes and proteins. So they're in different tissues and have different patterns across species, but you can see high levels in largemouth bass or bluegill, or other species. Okay, so step 8, selecting size ranges. This is of the species that you're monitoring. It's generally good for consistency. OEA has guidance for this based on legal limits and edible size limits. So in general, swamp follows OEA guidance. Wes will go into this a little bit later, but there's a couple of additions that we do. So for black bass, given that size relationship, we also get sublegal fish so that we can factor out the size concentration relationship and get better data. And for prey fish, we use a range of 25 to 100 millimeters to try to provide some consistency there. But having a size range helps reduce the variability across samples. Selecting sample numbers, another topic that I could talk at greater length about, but we don't have time today, but very important. In general, follow OEA guidance if you want to provide the information they need for advisories. Impairment listings or delistings also have sample size requirements, certain numbers of fish that they need. The numbers of samples are also critical for statistical analysis if you want to do stats with your data. More samples give you more power, but they're more expensive. So there's a balance of statistical power and cost that you need to figure out. And then importantly, also you need enough sample mass for all of the analyses and archives. So for the RMP, for example, increase the number of shiner surf perch per composite because we want to do so many things with the samples that we get from our shiner surf perch. So statistical design is another potential training topic, but if you need statistical conclusions, then you should think this through carefully. For a larger program, there's a question of fixed stations versus random stations. Isn't going to apply to smaller studies, but larger programs have included power analysis. We've done some in swamp, RMP, the Delta RMP as well. If you have the resources and the stats really matter, then you should do a power analysis. But the smaller studies can leverage the larger programs by using similar designs and using the statewide data set for comparison. Whether to analyze samples as composites or individuals is another key design question. Composites are usually used for expensive analytes like PCBs, where you take a larger number of fish. put them in the basomatic and make a homogenate from all the fish, from fillets. You take a fillet from each fish and then combine them in a blender and make a homogenate. You can represent more fish with fewer analyses that way. We typically use 5 per composite in swamp and the RMP. So that's a great cost saving measure, but the data still are representative of the larger number of fish. For mercury, we often analyze individual fish because the analysis is less expensive and the individual data are valuable for, well, I'll explain why that is. So a more powerful approach for mercury is to take into account that relationship of concentration with age and length. If you don't do this, then your data are going to be very noisy. So you could either use a very narrow size range or use a wide size range and use statistics to remove the length effect. So this is an example of largemouth bass data from the swamp statewide sampling in 2019. This was just some of the lakes that we sampled for bass that year, but can see the general increase of concentration for each location with size in millimeters along the bottom. Like one example here is Sulahuli Lake that has high levels, and you can see this linear increase with size. To take that size effect out, you can just basically do a linear regression of the mercury versus length and come up with a regression line and use that line to estimate the concentration at we use a size of 350 millimeters. We length adjust all of our data to 350 millimeters. And this gives you a really precise indication of mercury in that lake or that river location for largemouth bass. So this is again another topic that I could spend more time talking about, but we've done this technique for over 200 lakes throughout the state to come up with a length adjusted mean. These means are really good indices of contamination in the lake. We've seen like the results done this way are very stable over time, surprisingly consistent. And when we go back and sample a lake 5 or 10 years later, usually the levels are very consistent this way. But you can see the wide range in variation from cleaner lakes, which tend to be in Southern California, to lakes like in mercury mining zones like New Almaden, Guadalupe Reservoir and Almaden Reservoir at the top. So we got this great data set that you can see where your lake fits in using this length adjusted bass index. So I'm not going to spend much time on these due to time, but I developed these illustrations of the design for our lake sampling, showing how the designs vary for the different species and contaminants. So for the predator species, we collect fish from a range of small to large, and we need 10 samples to do a regression, and then we come up with a lake-wide length-adjusted mean. We also take some of the large legal-sized bass and make a composite that we can use for organics analysis. So we analyze mercury in all the individuals, and we can use a composite for the organics. If we don't have a bottom feeder, then we use largemouth bass for organics. For the bottom feeders, when they're present, like catfish, we in a small lake, we take fish from throughout the lake and create these composites of 5 fish. and we'd like to have 2 of them if possible. So I've got these illustrations for a small lake, and then for prey fish, we also do composites. And for both mercury and selenium, take fish from throughout the lake and make one composite for each species. For medium lakes, you go up to 2 locations per lake, and the diagram kind of shows all the details. So these are in here for reference. Another key topic is what tissues are of interest, another key decision point. The state programs have generally used fillets without skin, and that's what's used in advisory development as well. But there are other possibilities, and a lot of communities don't always eat fillets without skin. So you can look at another thing that we do in like the RMP for small species. We look at fillets with skin, but since they're hard to fillet, we just chop off the head, tail, and remove the gut, and that's what we do for small species like shiner surf perch. But community members may eat fish with fillets with skin on, or even whole bodies. So this is where it's up to the community what their priorities are, what the most common methods of consumption are, and how they want to characterize that. In the realignment work in San Diego, the stakeholders wanted whole body analysis, so that's what we did there. So locations, Wes is going to discuss. It's important to plan the handling and archiving and QA. It's really important that you handle the samples to prevent contamination. For PFAS, for example, you have to make sure that nothing with Teflon touches the samples. For microplastics, you have to be aware of like things that may introduce fibers or other plastic particles into the samples. So it's important to be careful about that. It's nice to have extra samples for archiving. This is an important insurance policy in case something happens to your samples. Sometimes samples jars break or get lost, or the lab analysis doesn't, something goes wrong. So it's good to have backup samples. And then also it's good to archive them in case you want to analyze other contaminants in the future. You also need extra sample materials for QA samples. And then figuring out what sample jars you need can be complicated. If you have a lot of analytes in a big program, there's certain jars that the labs use for their immediate analysis, and then other jars that are good for archiving. And figuring out the jars and the amount of sample needed for each analysis can get a little complicated, but it's really important. Okay, assembling a team. This is something that you might come earlier in the process, but you need to identify people to do each of these elements: lead the study, collect samples, process samples, analyze samples, manage data, analyze data, and write the report. On chemical analysis, it's important to choose your labs carefully. This is a good place to consult with experts. You should consider the quality of the data the lab produces, their detection limits, their responsiveness, and their cost. But if you're not careful, you might go with a lab that may be less expensive, but produces data that the detection limits are not adequate, or maybe you get a lot of non-detects for your PFAS or your PCBs, and you waste the money. So you have to be careful when selecting labs. Okay, I'm reaching my conclusion here. Then you develop a budget, and there's it's often a trade-off. Figuring out how many samples you can collect, how many analyses you can do, depends on how much money or resources you have. So this is another sometimes complicated thing when you're doing it for a big program like I am right now with the RMP. And then you need to develop a timeline. And for time consideration right now, I won't go through all the steps, but basically, in general, you should start planning a year in advance, because it takes a while to get a plan together. And then a key step is applying for a collection permit. And this, to get the permit processed, the application process takes several months. So it's best to do that maybe half a year before you want to start sampling. So say you want to start sampling next summer, 2025. The planning should start this summer. Have a draft plan that's together enough that you have the information you need for a collecting permit, knowing the locations and species and numbers that you want. You can do more refinement later, but you need that information to apply for the permit. And then while you're waiting for the permit, you can set up your contracts. You can finalize the sampling plan, work out all the details in a QAPP, and then if you get your permit by April and you can begin sampling in May, sample through the summer. It takes a while to have the sample processed and have the labs do their work. So you might get the data 6 months later. And then if you want time to write the report, draft report and a final report, you probably have a final report about a year after the monitoring is complete. So it's a general timeline, but it's important to know that it does take time to get the plans in place and the permits and all the paperwork, and then it takes a while to get the data. Then with all that, you can write your contracts with your partners as needed, incorporating the budget and timeline info. Important to build in flexibility, because when you're out fishing, you never know what you're going to get. And for small studies, there might be simpler arrangements than contracts, but you need to have some kind of arrangement with the groups that you're going to work with. Okay, I covered the collecting permit, and then when you've got it all figured out, you capture all the details in a sampling plan and QAPP, which Tessa will go through in more detail later. Okay, that's my part. So any questions?
Yeah, we have a question in the chat that might be answered with Wes's section, but I'll ask it anyway. So for listing a water body for fish advisories, is the rule still to gather 3 fish of the same species from the same location? What is considered the same location, big, medium, and small water bodies?
Yeah, good question, Sherry. I'll get to that in a few minutes. Thanks for teeing me up.
Yeah, it's a great segue.
And actually, before you dive in, Wes, we usually try and have a break around now. This is about halfway through our allocated 3-hour period. So I just wanted to do a quick reactions poll from folks. So if you would like to take a 10-minute break now, head down to your reactions and give us a green check mark. Yes, please, we'd like a break. If you want to keep on pushing, go ahead and give us like the blue arrows. Okay. I see quite a few folks that would like a break, and I am one of them. So why don't we take a 10-minute break, and we'll come back at 10:42 and pass it off to Wes, who will take us on to the next section. Sound good?
Sounds good.
Sounds good. Thanks, Anna. Just want to thank Jay and Jerry for teeing up some of what I'm planning to present. And what I'll be primarily talking about is in a document that we produced about 2 years ago, 2.5 years ago, called the Protocol for Fish Sampling and Analysis to support the development of fish advisories in California. And this is kind of a a synthesis of the US EPA tome that's many pages long in the hundreds, and then all of the swamp documentation. We wanted to try and put together a shorter, more user-friendly protocol that pulls out specific elements for fish advisory development. So some of this may be a little repetitive from what Jay discussed. So and feel free to stop me if there are any questions. So in this document, we put together about 9 different steps, starting with target water bodies, which for this context, I think most people probably know what water bodies they're interested in monitoring. Target species, and Jay used the term priority, but we use that interchangeably. Target analytes, sample collection, sample handling, and documentation. So that shouldn't be a bullet there. Sample preparation, chemical analysis, and data submission. And for this talk, I'll just be focusing on target species, target analytes, and sample collection, because most of the other steps we basically cited and paraphrased some of the swamp protocols, because we rely on swamp and CEDN for around 98% of our data or so. We're heavily dependent on CEDN. And then so target species, and this is very generic, high level suggestions for new water bodies, and we would definitely recommend that people wanting to sample at specific water bodies to look at species that are of interest to them. So we generally try to look for tribally or important or subsistence important species, so that we get a good understanding of what people are eating and collecting. Although that's sometimes hard for us, and most of us are in Sacramento, so we really rely on different groups, whether it be water body managers, local tribal communities, non-government organizations, or regional water boards, to provide us with site-specific information. And some of like Jay mentioned, for the higher contaminant species, we look at black bass for mercury, a lot of times largemouth or spotted bass, and then catfish, carp, bullhead, suckers for organic data. And for all the reasons Jay mentioned, those tend to be the worst actors. So we usually classify and look at our data based on those 2 species. And then for lower contaminant species, we'll typically focus on trout if they're available, or some prey species. We've really made an effort to try and include prey species that may be important for groups who consume those species for subsistence, tribal, or recreational purposes. We're just trying to be as inclusive as possible with the data that's out there, and welcome feedback as to what other species folks are interested in. And then for target analytes, we generally focus on what we have ATLs, or advisory tissue level, for, and I'll discuss ATLs further in the training in next fall, discussing the development of the fish consumption advisories. So mercury is the worst actor and the most common element that's present in fish, and one of the worst offenders. Selenium is present primarily, it seems, in the south, and it's localized to certain areas. Selenium's interesting because the right amount of selenium is required for health, but too much can be toxic. So it's one of those rare things we need, but too much is not good. And then industrial chemicals we look at are polychlorinated biphenyls, or PCBs, which is probably the second most common chemical that derives advice for species of fish in California. polybrominated diphenyl ethers, or PBDEs, are lower, tend not to drive too many advisories. I think we only have 1 or 2 advisories for PBDEs. And then legacy pesticides, which are chlordanes, DDTs, dieldrin, and toxaphene. These aren't quite as common. DDTs are present off of LA region due to the Superfund site down there. And we have a handful of water bodies throughout the state where these compounds, the legacy pesticides, are of concern. Sample collection. This involves 4 steps, as you can see here, and this is just an image of some mussels that we collected during an oil spill, following an oil spill on Huntington Beach. Just to give an idea of maybe a sample size that's required. And we only look at PAHs and these analyses, so everything, our numbers are driven by that specific analysis. But for sample collection, timing wise,
Hey, Wes,
yeah,
before you move on, we got a question in the chat.
Okay.
About the analytes. What are chlordanes found in? A typical brand name of a pesticide, something like that?
That's a good question. These
answer
are
that,
legacy
but-
because, oh, go ahead, Dave. RJ.
Chlordanes were a pesticide that was banned in the 80s. I think Decloran was one of the brand names, but they've been out of use for a very long time, so it's probably not anything anybody's heard of. They might be on a rare person's garage shelf, but they should be out of use, but they still show up in the environment because they're very persistent, like DDTs and PCBs.
Thanks. And then Sarah, I see you had your hand raised. Did you have another question or anything to add there?
Yeah, I had a question about dioxins. I mean, I guess with this target analyte list, you know, because dioxins are something that could be found after wildfires, especially with homes burning. And, you know, I mean, we had heard from the regional board that that would be something to test for in fish, you know, within a couple of years after a big fire. Just wondering, like, how you come up with the target analyte list. And I'm assuming it's purely health-based. But if there were things that would be levels that would affect the actual fish health, would that be, this is question number 2, would that be sent over to California Department of Fish and Wildlife to do further studies on, or how does that work? Or maybe you'll get to that a little bit later.
No, those are good questions, and 2's the easiest. That would likely go to Water Board or CDFW. We don't handle the aquatic toxicity or ecotoxicity. We focus only on the human health. I mean, there have been instances where we've looked at ecotoxicology in the past, but that's not currently where we typically work. And then getting back to the first part of your question, as far as what chemicals we have developed ATLs for, some of it's due to what is looked at nationally, and then also what chemicals are detected in certain frequencies throughout the state. Throughout my time at OEHA, we have not developed and released a new ATL. These ones were all developed in approximately the 2008 era. So that's a good question. And we are working on PFAS because we're seeing, as Jay discussed, detects in San Francisco Bay and across the country. Again, it's sort of a wide-standing problem that we're starting to seriously look. We've been looking at it, but really seriously working on it and interacting with the Water Board closely on occurrence in fish tissue. As far as dioxins go, that's an interesting question. I think it's something in the past that has been considered, but I don't really have a history on dioxins. I definitely could go back and look through our files on that, because we've lost a lot of our kind of historical context with Bob Brodberg and Susan Klasing and Margie Gassell and some other folks retiring. But I know that has been discussed in the past. So does that answer your question, Sarah, or anything else you'd like to follow up with?
Yes. Yeah, thank you. And it sounds to me like this could be a spot where tribes could, you know, potentially identify other things that might be on should be on OEHA's radar.
Yeah, that would be great. Yeah, and hopefully this workshop will really just sort of be the beginning and continuation of new relationships and continuing of old relationships we've had as far as interaction for biomonitoring and bioaccumulation monitoring. So go. So timing. For timing, we suggest that people mimic typical harvest times. We want to see what the levels of contaminants are in fish when people are actually collecting and consuming those fish and shellfish species. Sometimes I know the sampling season doesn't necessarily isn't at the same times as when some species are collected, especially during the winter months. Some of the important things there are just with different spawning or fluxes of different types of contaminants. But it seems like a lot of the contaminants we do have data for, these are long-standing contaminants that don't vary a whole lot on the time scale of decades and or at least years versus harmful algal blooms, and some other PAHs can really change relatively quickly. So they're different types of those short-lived chemicals or short held on to chemicals we're looking at in developing new protocols to try and deal with those. Domoic acid and some of the marine harmful algal blooms are different area, or another area that there's a lot of coordination, rapid response that needs to take place for those health advisories versus the typical fish consumption advisories for the long-standing chemicals. And we also generally look at fishing regulations for people to think about when sampling is done, both with respect to seasons and sizes, which I'll get to in a minute. And I previously mentioned that fish may contain different levels of contaminants while spawning due to the increase in lipophilic compartments of their body, which may accumulate more of the organic compounds such as PCBs. And then locations, known areas of fishing activities, clearly important. And Swamp, I think, does a pretty great job of hitting these areas, and also areas of known or potential point sources of contamination, such as the Sulphur Bank Mercury Mine on Clear Lake is an obvious site. For the most part, I don't think we've seen too many statistically significant differences to change or have specific advice for certain areas, but Southern California and then the Lauritzen Canal are two areas, or Lauritzen Channel are two areas that come to mind of just very different amounts of contaminants that result in either do not eat advice or do not consume, or much more restrictive advice than the surrounding areas. And this generally requires a lot of sample collection to really tease out these differences, especially with species that tend to move more versus species that are more localized. So that's where we really work with Swamp and other people with more biological understanding of the different species and their home ranges or their different habitat ranges, because we are primarily public health, trained in public health and toxicology with sort of applied knowledge when it comes to the ecotoxicology or the fate and transport. So we do rely on our partners and other experts for that information. And then getting back to Sherry's question, our typical recommendation for a water body of all sizes is 3 species and 9 individuals per species. But staying with sort of some Swamp's numbers, we put together this table that corresponds for lakes and reservoirs with those sample sizes. So for a small lake, just as Jay mentioned, we recommend 1 sampling location with 9 individuals. And then for a larger 500 to 1,000 hectare water body, 2 locations and 5 individuals per site. So we got a total of 10. And then 1,000 to 5,000 to the 4 sampling sites, and then 10 to 20 individuals per water body, and then so on and so forth, with more for larger water bodies. And again, we would like for people to collect 3 species. Sometimes that's not always possible, especially for some of the smaller water bodies and creeks and rivers up in the mountains, where there may just be 1 or 2 species of trout. But it's also helpful to have other prey species so we can increase that list. And that's just so we have confidence in the data, so we have confidence in the advice we produce for that specific water body. Rivers and creeks are really site-specific consideration. General idea is 1 sampling location per 25-mile segment, and then recommended 3 to 9 individuals per 25-mile segment. And this may change based on the water body. If it's something that's going from headwaters and rapidly down to more of a valley river, we might want more sampling locations, just so we can be sure we're getting good representation of what contaminants are in those and the level of contaminants in those fish and those individuals. Estuaries and enclosed bays are another size dependent and site specific, because we have certain simpler enclosed bays, but that might be more impacted by urban sources and vessel traffic, and then other very complex estuaries such as the Delta, where there's a lot of inflow from various rivers and then tidal flushing, as well as different anthropogenic and urban inputs that can really change the levels of contaminants. So those sampling situations are much more complicated. And then the open coast, we generally recommend about 3 blocks, which are CDFW trawl blocks. And there are a variety of maps where those are shown. And that's just to get, because the coast is so widespread and varies from the north to south and by depth so much that we're just trying to get a good sampling, but be reasonable and not requiring, sampling in every block to really get a good understanding of those ranges and contaminant spreads. And then 10 species per block. And the coast cruises through swamp and the bite programs are give us really good data for those. I know it's difficult and there's certain species we're interested in, but they tend to occur in very specific places at specific times of the year. So sometimes it's difficult to get those species. I know California halibut is something we've discussed some, but along the coast, there's only certain regions where those can be collected reliably. And then all this information is extracted or is in that document, which is available on the web, which will be in a link provided by the slides once Anna sends that out.
There's a couple of questions in the chat, Wes.
Sure. Yeah, I haven't really been seeing those.
Yeah, so
Sarah
the first
asked,
one, go ahead, Tessa. You got it.
No, you go.
Okay, so the first one was when you were first talking about locations, and you mentioned some specific examples of locations, and someone was wondering if those were have specific locations that you were citing as examples, or locations particular to methyl mercury or the usual analytes.
As far as point sources,
I think Lauritzen in Southern California.
Yeah, those are DDTs are some of the primary contaminants there. And I don't know the full story on the Lauritzen, but I know there's a lot of contaminants in the sediment. Jay, I'm sure you know better. They're very high, and is it chlordanes and DDTs?
Mainly DDTs. There was a DDT packaging facility there that spilled a lot.
Yeah, and then Southern California was the Montrose Superfund site. So there was a lot of dumping of DDTs and PCBs, and right now there's an effort to do some deep water sampling because there was more dumping that took place than was previously really accounted for. So we've been working with some California Sea Grant and various folks to be engaged on what they're finding and what future work may be. But we're also involved with the Fish Contamination Education Collaborative down in Southern California, and that's part of the Superfund site there to develop risk communication and risk management programs for local anglers and fishers.
Perfect. Thanks, Wes. And then the other question was, do we have equivalent information for plants at this time?
That's a good question. We have not historically worked on plants to the best of my understanding. We would have to do some thinking and develop some exposure scenarios and do some literature work as far as the absorption from plants, because different matrices affect the absorption of those chemicals from the gut.
Yeah.
So
So I can provide a little bit that is coming up, and maybe SFEI and you know, maybe Wes or Jay, you guys might be good people to be peer reviewers, but it looks like San Diego has put in a grant to do some plant uptake studies for different toxins related to the tribal beneficial use work. And that's a pending EPA EJ grant to be more updates later.
Yeah, that would be very interesting. I know we've received requests in the past, and I wasn't in a position to make decisions or determinations on that, but it's something very interested in. Both plants and other forms of wildlife would be of great interest. You know, anywhere we can try and have data and provide advice for individuals consuming those plants and animals. Thanks for that information, Sherry.
And thanks for reading my brains, Sherry. I was going to ask you to speak up about the work that you're talking about. So thanks for that.
And was that it for questions?
Yes. Thanks.
Cool. Okay, and then fish and shellfish size. So we generally stick to legal limits, or when there are no legal limits, we use edible minimums, which is the length at maturity. And we generally look at, there's a few databases, one called FishBase, which is an online resource. And we use those numbers so we can get a good approximation of what the highest levels of contamination are, because we're trying to develop the most health protective guidance possible, knowing that there are sometimes very wide variance across contamination levels in fish. So we're using that as a sort of a biological basis to provide our advice and have some level of consistency across species. And I want to also, one thing I was thinking about when Jay was talking about the normalized length for certain species, as far as bass goes, we don't generally do that because the contamination or chemical level across either age or length varies across species, and because we're not looking at one species across different water bodies as SFEI does, because we have different goals in mind. So we take all the species or all the individuals that are above legal limits or above the edible minimums to develop our advice. And we really work to make sure we have at least 9 individuals above those minimums. And again, those are spelled out in the sampling analysis document. We have a list of different species and what those edible minimums are. And then the CDFW regs will have the legal limits. And that is the end of my talk, or my section. I don't know if there's any additional questions.
think before we move on to Tessa, just wanting to flag for folks that a link to tribal exposure scenarios was added to the chat, and I'll be sure to add that as an additional resource slide before we send these out, so folks have that.
Okay, I think I'm sharing my screen now. Great. Hi, I'm Tessa again, coming back around to finish this up. I'm going to talk about data quality and data management. So I think we're going to start off, Anna's going to put up a poll about your level of experience with quality assurance project plans, or QAPs, project plans, whatever you call them. Are you? Oh, there she goes.
Yes.
She's on it.
This one's pretty fast, so we'll only give it a minute or two.
Well, looks like almost everyone's got some experience. That's good.
We've got 61% of folks have taken the poll. And I think a couple of folks aren't going to take it, so we'll give it another couple of seconds. Nice. Okay. We've got 85% of folks have participated. 90, great. Okay, so I'm going to close the poll so that we can check out the results. So we see that over 60% of folks have written, contributed to, or updated a QAP, which is highly technical and a very heavy lift. So good for y'all. About less than 30 have followed the procedures in a QAP, which is awesome. And there are a couple of us who don't have any experience. So awesome.
Okay, cool. Thank you. So I'm gonna keep this pretty high level, not going into all the details of project plans, but just wanting to start out. Your goal here is really to document the monitoring design elements. So like all those things Jay and Wes just talked about, you want to document all of those decisions that you're making, and in a way that includes all the procedures that your team members are going to follow to make sure you get the results that you're looking for. And the size and complexity of your project should be reflected in your plan. So if you're doing a huge statewide or bay-wide project that's going to be ongoing for years, you're going to have a longer, more complex plan. But if you have just one or a few smaller water bodies that you're going to do a 1 or 2 year study, you're going to have a smaller document that you need to write that can be more simple and reflect that. So I know project plans and writing long documents is not always very exciting, so that's why I'm bringing in the cute cat pictures here. So just a little bit on terminology. A QAP, as some people call it, quality assurance project plan. I think that is a US EPA term, been used for quite a while. And if you've done any work with US EPA on a grant or something, it's often required if you're doing a monitoring project. Basically, that's how we are required to do them, because the water boards, we get these big block grants from US EPA. And so then we're required to write QAPs for all the monitoring we do with EPA funding. So that is a project-specific plan designed to provide the type and quality of data required to answer questions posed by the project. But really, it's just, you want to document all the things you're doing, like why are you doing it and how are you doing it to get to the answer you want. QAPs typically can cover a 3-year period, although I've seen different guidance throughout the years. If you do have a longer term project. And then there's some other terms people use, a monitoring plan. In our program in SWAMP, we use that. We have a QAP that kind of covers our entire program, but then we do a monitoring plan each year that as we adjust each year, where exactly are we going to go? Which species are we really targeting? Which analytes are we going to do this year? And sometimes that's based on looking at the data we collected the previous year to see what should we do this year. So that one, it's sort of like an addendum of just a shorter, more concise list of like the specifics for this year. Now, if you have a small project that's only 1 or 2 years, you don't need to have that. That can all just be in your one plan. And then there's another term, sampling and analysis plan. That's another term that US EPA uses, and that's typically used for like a one-time or limited time sampling event. So it's just meant to be smaller than a QAP. A QAP is typically for something that's like more planned out, thought out, might be longer term. But I kind of just like to think of it as your project plan, whatever you end up calling it. You know, if you have a requirement in a grant or something, use that term, but you're just documenting your plan for your project. So it can be simple and straightforward. The EPA guidance, you know, it's got like 24 elements that need to be in your QAP, but it doesn't need to be this like really tedious exercise to get there, because it's really trying to get at like the who, what, where, why, when of your project. And you want it to just be very specific to your project. And, you know, there might be sections that just don't even apply to your project, and you might have the heading in there and just say like, not applicable. You can just move on sometimes. And what I would really want to encourage you to do, so you can be happy like this little cat, is just think of future you or future your organization. What are you going to want to remember about this project that you did, that you may not remember in detail a few years later, but when you're looking back maybe at what you did, you want to do another similar project, or you want to think about that data again. What are you going to want to remember? And that's what you should be documenting in this plan. We do have a resource that we'll share in the links later. We call it the QAPs Made Easy workbook that SWAMP put together a couple of years ago. And it tries to take you through these like systematic planning 24 elements of a QAP in just a more sort of easy to understand plain language type of way, and then help you kind of translate it into the EPA sections. But the idea is, you know, you're going to make a plan systematically, you know, going through those steps that Jay talked about, and then you're going to put that documented in your plan. You're going to implement it, and then you're going to assess your data later, and then that can inform future planning for you. So that's just kind of the general project management lifecycle and where a QAP fits into it. And so the questions that like this QAPs Made Easy workbook takes you through, we refer to these as data quality objectives, because you need to be able to answer these questions to get the data of quality that you need to fit the purpose of your study. So these seem, you know, I think I know you could write an essay on each of these, but these are just kind of like to get you started thinking of, you know, what are you going to study? How are you going to use the data? Like, are you wanting it to go into a fish advisory, or do you have a different purpose? And then that's going to inform, you know, how much data you need to collect of what type. So I think a lot of these questions sometimes feel obvious, that you almost don't need to write it down. Like, oh, well, the reason I'm studying fish is because I want to know what's in the fish. But sort of laying it out in a cohesive way can really help future you or future staff or people who might be looking at this of like, oh, why did they do it this way? So just thinking that out and laying it out in language people can understand in the future too. You know, what data and information are needed, what are the limits, what decisions will be made, how much error is acceptable. So those are kind of the high level questions, and then the workbook takes you through how to get to the more detailed answers of those. So data quality, how do you ensure the quality of your data? It starts with planning. You want to think through, how do you want to use the data? What quality do you need to make that decision? And then, you know, make a good plan for how you can collect that data of the quality that you need. So, you know, one way to really do that is trying to use standardized procedures, standardized methods for collecting your samples and analyzing your samples. That goes a long way in making sure you have quality data. So kind of using time-tested procedures or creating your own standardized procedure that you're going to continue following, at least for this entire project and maybe others. So having those standardized operating procedures, like those SOPs for how you collect things, how you prepare them, send them to the lab, et cetera. And then using a lab that is using a good quality system. So basically, overall, big picture data quality is you want to develop and document your plan, train the team to follow that plan, and then follow it. I know it seems simple, but I think sometimes people just feel like a QAP is this annoying requirement, but it really does serve a purpose. It can be a good tool. So more on data quality, how do you assess the quality of your lab data? So you want to pick a lab that you can trust that has a data quality system in place. And then you want to include quality control samples in your plan. So quality control samples are a way to assess various data quality indicators. Like the ones we think of mainly are like accuracy, precision, sensitivity, things like that. And then you want to compare the results of analyzing those quality control samples to your acceptance criteria. And you want to set up what are your acceptance criteria. And before you send your samples to the lab, you want to discuss that with them, that you're going to include these quality control samples, you want them to analyze them, and maybe you tell them what your acceptance criteria are. And most labs have their own acceptance criteria, and yours may be the same or they may be different. But you would just want to document that in the QAP. So for example, SWAMP program, we have some measurement quality objectives, which is another term for kind of those acceptance criteria. We have two categories for tissue. We have inorganic chemicals that would cover like mercury, methylmercury, selenium, any metals. And then we also have another set that's for synthetic organic chemicals. So like PCBs, PBDEs, the DDTs and other organochlorine pesticides, also includes PFAS. And you could generally use them for any type of organic chemical. So those are documents we have posted online, and we'll share those links, but it basically gives guidance on what quality control samples you would want to include, like laboratory duplicates, a blank, a matrix spike, things like that, and then what your acceptance criteria are for those. So the lab will basically take a blank sample and spike the chemical in it and make sure that the lab is able to analyze that chemical to the concentration they expect to find. And so like you want to make sure it's within a percentage of what they thought they put in. So we have those acceptance criteria for like percent recoveries on spikes and relative percent difference when you basically analyze the same thing twice and see, did we get a close enough answer each time? Because if they're hugely different, then you feel like you can't trust the lab's system. So this is kind of getting into technical nitty-gritty stuff, but when you're developing your QAP, we kind of have some resources that you could basically copy and paste from, or at least look at to get an idea of what you would maybe want to include for your monitoring. So these, we really just have tissue. We do not have any of these developed for plants, but it may, you could get a sense of what you would maybe want to start with for other things. And I'm gonna kind of switch gears to data management. So just thinking about data in all the different forms that we might collect in your project. So just record keeping in general, like when you go out to collect samples, usually people bring a paper form to collect information about, you know, their location, the time they collected it, you know, maybe some observations of the weather, if is it raining or sunny, a lot of details like that of where exactly you collected it, you know, maybe your GPS coordinates and things like that, that you can record when you're out in the field. So a lot of times people have a paper copy of that. Sometimes people are doing electronic field sheets. A COC, chain of custody form, is for you've collected these samples, now you're gonna take it to a lab or someplace to be processed. So you're kind of transferring custody. It's a way to track that the samples are sort of maintaining their integrity throughout the transferring process. And it also, usually when you drop off at a lab, they want that chain of custody that really specifies exactly what the sample is and what you want analyzed. But it's another document that we usually retain to kind of be able to look back and show the documentation of this project, and that, you know, if there's any question about a sample later. And then eventually you'll get your lab results. Sometimes most labs will give you a PDF report that kind of describes all the results. And then sometimes they'll also give it, they'll ask you if you also want an electronic version, like in an Excel spreadsheet, basically, that they refer to as an EDD, electronic data deliverable. So those are just the different kind of records that you might collect in this type of a project, and that you would want to retain and store just for future reference. Data entry is a piece where you're taking your paper sheet from the field and then entering that maybe in a spreadsheet or different electronic format to, you know, be able to save that way. And then you'll also get your lab results. You can get those in an electronic format. So those maybe could eventually go in a database or be submitted somewhere if that's of interest. And then one piece is also reviewing the data. So, you know, even just entering those field data from your data, your field sheet, you know, there can be errors. So it can be good to have someone review that. Make sure you didn't make any mistakes on like the water temperature, you know, just those basic things. So these are kind of like the main pieces of data management that we think of that you would want to document in a QAP and make sure you have thought through before you get started on your project. And then let's see. So I just am giving a little example of how you might want to describe in your plan your whole kind of like data path. So kind of how data are recorded, reviewed, and stored, and then processed, compiled, and analyzed. So you kind of start with collecting fish or whatever it is you're collecting in the field, and then eventually those samples get to a lab and get analyzed. Then they get into like a spreadsheet or something for you to look at the results. Maybe that goes into a database, or you just store it, you know, in your own organization. Maybe you get that posted online or in a written report. So just kind of thinking that whole path through from collecting things out in the field, recording things about it, and then getting it all the way through to the end in maybe some sort of report or analysis. So I just have like a couple of examples of sort of like the details of that. It's a little long, I know, but you can refer to this later maybe if you're writing your plan. But you know, just all these steps can seem minor, but having it written out in your plan is actually really helpful. If a question comes up later, you kind of know where to look and who to talk to about things. So, you know, like you record your results on your paper field sheet, certain staff enters that into an electronic format, so a different staff reviews it to make sure there's no errors. Then those are stored on, you know, maybe on your local computer or your cloud, or do you have a backup for that? Is there, can you recover that if your server goes down or something? And then, you know, your field data, maybe you have an internal database, maybe you're submitting to a external database like EPA's WQX, or we have the water boards, our CDIN database. You would just want to lay out all those steps. And then, so that's field data. And then similar for lab results, like you, your samples are submitted to a lab with that chain of custody form. Maybe you save an electronic version of that, even just a photo or something. So you have a record. The lab will give you results. You know, you need to save that somewhere. Someone should look over those results to see, do they meet your acceptance criteria that you set out? Do they meet, if you need it in a certain format to give it to a database, did they give it to you that way? And then getting it into maybe your internal database or an external or wherever you're going to store it. So just thinking all those steps through and laying it out. So that's the end of my piece. So we're kind of opened up a little bit here. And then I think still have a little time to go through an example.
Thanks, Tessa. I think before we jump into questions, I just want to reiterate that the statewide swamp bioaccumulation monitoring program CLAP, please use that as a resource. I added a link to the chat. There will be a link in the slides as well, but there's no need to reinvent the wheel if you're going to do the exact same thing. So please copy and paste. And if the PDF is not working for you, reach out and we'll give you a Word version. Our CLAP is close to 80 pages long. So like if you're trying to do a one-to-one, I don't want to have you guys do that if you don't have to. So with that, are there any questions for Tessa or Wes or Jay or anything folks wanted to follow up on before they go through an example?
Yeah, I want to say that I think if people do have questions, I think that would be a priority compared to the examples, and we're running out of time a little bit. So let's answer any questions people have, and then if there's time, we can work through our examples or maybe entertain examples from the group.
Yeah, and you were kind of getting along to what I was thinking, Jay. We're in a room with 23 other folks, including myself as 24. You all are experts in your own right. So if there's things that you heard from, you know, Wes, Jay, or Tessa, those are examples from our experience running the statewide program, and they might look markedly different from your experience running your own monitoring program. So if there's anything that you want to flag for other participants or share as a hot tip that like, okay, you know, Jay said to do this, but actually what really works for us is that, you know, please use this time if that's something you want to share. And again, if you'd like me to pause the recording before we go into that discussion or before you speak or anything like that, please let me know.
Well, folks are thinking, one thing that came up in the chat and we did talk about a little bit was monitoring plants. And I said in the chat that we should talk about that more later. I have a couple thoughts on that. Well, first of all, I have no experience monitoring plants, and I think our trainers are probably in the same boat. So we don't have direct experience and expertise on it, but I think a lot of the general outline of steps in designing monitoring still apply. But a couple of thoughts, Anna, for our state program. Javier offered a link. No, I'm sorry, it was I think Sarah offered a link to Oregon guidance, and I think maybe the statewide program can start collecting resources like that on plant monitoring, and find a place on our safety work group webpage to share those. Another thought is we could potentially have a presentation at one of our STU meetings by an expert on plant monitoring. So something like that's a possibility as well.
Thanks, Jay.
I would be curious to anybody on the call who's been dealing with plants. We're really trying to focus on protecting our weavers who use riparian willow and grapefruit. Some of the challenges that we're having are identifying funding, identifying labs that work with the plant matrix, finding past sampling protocols to use, dealing with the seasonality and dam removal at the same time. So we have a lot of open questions right now, and I'm just curious if anybody else has done work like that with basket plants.
Hey, John, this is Sherry. If you want to, can you hear me okay?
Yeah, you sound great, Sherry.
Oh, it sounded like I had to call in. It sounded, and my phone just told me that I was still muted. But so what we did was we worked with USGS and to do some sampling where we did soil, and then we sampled the plants themselves. We were looking for specific toxins, and what we noticed was the water was moving swift there. So the toxins, if they are there, were not settling. We know they're there because they showed up in fish. And this is kind of a new, this is a need across the state. So your questions and what you're asking for is in some ways cutting edge. But if you put your name and phone number and just write plants in there, or even your email, we'll try to find some folks for you to talk to, because we know that San Diego's just getting ready to start their work, and they're working with one of the colleges down there in San Diego. So we'll put you in touch and see if we can't start to build that with you.
Thank you.
And then also just flagging that Sarah Ryan from Big Valley mentioned that they've done that for Thule. So another resource to reach out to through making that connection. And then Sarah also noted that, or wanted to make sure we point out about equipment detection levels, needing the grams to be below the action levels, and that the AL for the tribal beneficial uses could be different. So just wanting to flag that and highlight that comment from the chat.
Yeah, it's always important that your method detection limits are preferably well below any thresholds that you want to compare them to. If when you're working with concentrations that are near the detection limit, there's more uncertainty in the measurements. So it's good to be, maybe an order of magnitude below a threshold that you want to compare to with your detection limits, but it's definitely an important consideration. Continuing on my thought earlier, Anna, about what can the state program do on plant work, and maybe a presentation by that San Diego group would be good.
Yeah, that sounds great. We can follow up. Sherry, if you can CC me on the group plant party, we'll be sure to make the connections. And then there was a question about seed-in versus WQX, and can someone describe the database relationship? I just want to acknowledge that this is something that requires much more time and conversation than we have today, but the training in September, September, Tessa and I are thinking about how to make more space for that. But Tessa, you're the seed-in expert, so if you want to take a stab at it, feel free. And then others who have worked in both, feel free to chime in too.
Yeah, I mentioned WQX today, but I don't have a lot of experience in it myself, but I just know if you have EPA funding, that's often the requirement is to submit your data there. CEDN is a database managed by the water boards, and if you want your data assessed in our integrated report for California, it does need to be in CEDN at this time. So that's just a consideration. The CEDN data submission requirements aren't extremely different from WQX, but there is more detail and more required fields in CEDN, I would say, compared to WQX. So if you're considering why you might report to one or the other, I mean, it would definitely depend on if you have requirements from your funding sources, you know, that would drive it. But if you have an interest in getting data into fish advisory calculations or in integrated report assessment, putting it in CEDN is the easiest way to get that flowing. But Sherry's got a hand up. I'll let her go on.
I'm wondering if Sarah, Ryan, you know that there's a connectivity where one database will upload into the other, but not vice versa. Do you know that information, Tessa or Sarah?
I do. Right now, so in the past, CEDN data was uploaded into WQX, but that hasn't been happening for a few years. Just the connection, for whatever reasons, I don't know the details, stopped working and was never repaired. So there's probably some older CEDN data that is in WQX, but it doesn't flow anymore. And we do not import WQX data into CEDN. So right now there is no connection, but there used to be.
So a couple things to add there. I actually was at the US EPA Tribal Conference and met with the CEDN or the WQX expert to talk about this issue. And we have started that conversation of bringing those connections back. It's going to be a long haul, but that's an active conversation that we're having between the California Water Boards and US EPA. And the other thing I'll note is the California Integrated Report, in order to get it assessed, they prefer that folks submit CEDN because it's an easier connection. But to my knowledge, because our integrated report team is aware of the disconnect between WQX and CEDN, I think they do a poll of WQX, and it's actually a big data issue for them to make sure they're not getting duplicates and things. So I think the data are being assessed in some capacity.
Only for water quality, but not for tissue.
Not for tissue. Okay, great. Thanks for clarifying that. That's super helpful. And then Sarah, you have your hand raised.
Yeah, I was just gonna say that the most recent integrated report did pull tribal data. And it is only pulling tribal data from WQX that are identified as final and not preliminary. So if you're submitting, if your tribe is submitting data as preliminary, just know that it's not going to be used in any integrated report. So, because they can't see it. But it is happening that the regional boards and the water are aware that tribal data is going into WQX. And I believe that they're also looking at all the other entities, you know, USGS and others who are putting their data in. So it would be foolish for them not to be using our data because it's good and we do a lot of it.
Yeah, I'll clarify what I said earlier. They do pull all the water quality data from WQX for the integrated report. But as far as I know, I just talked to them last week about this, they're not pulling the tissue data. So that's why I was just saying that, because we were talking about more tissue. So sorry for that misstatement.
Thanks, Tessa. Yeah, Sherry?
I have another question. So one of the things is we talked about collaborations, and you make, for example, if one tribe were to have a grant for harmful algal blooms and another was to have one for mercury sampling, for example, you could share fish And that way you're taking individuals and doing that. But in that process, sometimes we will store fish and use them later for another sample or another type of toxin we're looking for. At the time, it was 10 years, and I'm wondering what you guys think about the viability of storing fish and then shipping them out later for something else. About how long do you consider that sample accurate?
That's such a timely question, Sherry. We've been having this discussion at the Safety at Work group for the past couple of meetings. Maybe I'll punt this to Jay and Tessa to explain what our QAPs say, and then what the scientific community uses as a normal standard.
Yeah, so for the conventional contaminants, the persistent things like mercury, PCBs, DDTs, they're very stable. If the samples are frozen and there's not like a freezer burn, if they're like stored properly in appropriate containers, they can be kept for long periods of time at normal temperatures. Minus 20 degrees, like a normal freezer. We keep things for around 5 years. You could potentially keep them longer. I think 10 years from a just sort of a more research science perspective. There are programs that keep samples for 10, 20 years. If you really want to keep things for the long term, it's better to keep them at colder temperatures than that. And the RMP does some of that, but that's kind of a more elaborate thing. The QAPs have hold times of a year in general. And there are sort of regulatory reasons that I think they came up with that type of hold time. So to meet, it's good to meet those hold times, but if it's more of if the data are more like research oriented and not for regulatory use, then longer hold times are very acceptable in the scientific community. One thing that we've talked about recently that I need to look more into is the hold times for the algal toxins. I think that's a different story. They're not stable like the persistent contaminants. I'm not sure exactly what the hold times are. So I don't have a good answer for that one.
Well, thank goodness Sarah's on the call, because she just added to the chat that their Big Valley is finalizing their fish sampling SOPs and is going to share the info regarding preservation. And that they spoke to their labs, and for methyl mercury and cyanotoxins, they have shorter hold times than what we've just been discussing.
That raises I think something that's valuable to know about mercury or methyl mercury. We typically measure total mercury in sport fish. In fish in general, methyl mercury is the form that's really toxic, but in fish, most like 90% or more of the total mercury is methyl. But when you're looking at other species like shellfish, it's not as consistent or as much that's of the total mercury that's methyl. So for shellfish, it is a good thing in general to measure the methyl mercury, and that does have a shorter hold time.
Thank you.
Any other questions? We've got about 10 minutes left before we close today.
Well,
Do we have?
Go ahead, Autumn.
Hi, I just wondered if this is a good time to, like Jay did for the previous training session, put in a request for if there's anything specific that you want us to discuss in the next section regarding collections or laboratory processing, either let me know or send Anna and Sherry an email and they can forward it to me. We want to make sure that we cover what you want to hear about.
Thanks, Autumn. I think
something to consider that might be interesting.
To think of.
You're good. We can still hear you. I muted your Zoom person, so it's just your phone and there's no feedback.
Oh, thank you. I already done that before, but for some reason, I don't know. We noticed something about a lot of the communities and a lot of the places we're sampling are very rural. So when you're sending out your fish samples, try to send them early in the week because you don't want to get stuck with them sitting in the mail over the weekend. Fairly small things, little things like that to include in your clap and to think through. Do we have time to discuss the scenario, or are we too short now?
We
There's
could.
no other questions.
We could do a quick one. Is there one that you
I'd
would
say
request?
I don't know. We were talking about Clear Lake before, but is there, if there's anything that's pretty obvious to you that you think would be an easy one? I know Sarah, you're here, and others we've done some sampling out there. Oh, this is something we're thinking of, you guys. Also, what we have done in Clear Lake is we went out with Fish and Game, and they have their ability to do shocking, which is nice because the fish they recover, and so you can have more of a opportunity to choose what you want to take. That was useful for us because we could see if fish had sores on them, and we could specifically take those on purpose, knowing that they're probably not as healthful as some of the others that came up. Things like that to think about. But yeah, let's do a scenario if we have time.
Sarah, did you have something you wanted to add to that before we walk through a scenario?
Yeah, just that this Fish and Wildlife is usually pretty helpful with those types of things. You can jump on the boat with them potentially, and give them a list of the fish that you're looking for. They even if it's a listed species, they will work with you on that. We've been able to get quite a few fish that way, so I recommend it. Thank you.
So we had thought about a couple of lakes that OEHA thought was interesting, or a couple of locations that OEHA thought was interesting. We could also look at Clear Lake if you want. Name a lake. Should we do the one that OEHA thought about, or the one that you're familiar with, Clear Lake?
We're getting a thumbs up on whatever OEHA's familiar with. Was that the right thumbs up, Sherry? Did I interpret that right?
All right, so June Lake was a lake that Wes thought would be a good example. So I just typed the name June Lake into the portal here, and it popped up. So here's the location. You can zoom out to get a better idea of where we are up in the Sierra. It's kind of south of Mono Lake there. Here's the data that we have for June Lake. So what's showing up in the safety portal, which is drawing from CEDN, we sampled this lake in 2008 in the statewide program, but only rainbow trout. So there's only one data point. The concentrations were low, but as I said earlier, we sampled a lot of trout lakes and a lot of river stations with trout, and they're often low. And the problem is you don't know if they're low because they're just hatchery fish that were transplanted. So that's probably the case here. So Wes, why don't you give a little more background why you thought this was interesting?
Sure, yeah, I was going back and looking at this. I didn't do this analysis, but we do have an analysis showing that brown trout were relatively high, not much higher, but higher enough for it to stick out to us.
And yeah, and I was curious where the brown trout data came from. It must not be in Sedon, or
No, it may be another source. I would have to talk with Lauren. I think she did this data analysis,
yeah.
but it's one that we put on a list to prioritize for additional sampling to get more species there, just given that higher than average mercury concentration.
Yeah, and brown trout, in some cases, accumulate higher mercury levels if they're like a resident population. So that's a different different situation than for rainbow trout. So in general, we have seen some high mercury levels in brown trout.
Yeah, and I think I suggested East Walker for the same reason.
I'm going to switch the map over to brown trout. Oh, but that's, sorry. I'm going to reset, show brown trout, just to show some of the things you can do. So we did measure brown trout in Silver Lake nearby. It was also pretty low. So something to note for June Lake, we that in the data that show up are from the first statewide survey, and we were not doing crayfish at that time. So it would be interesting to know what the preyfish are doing to see if it's good to have kind of a another indicator to support whatever you're seeing. Like if there is an elevated mercury signal in the brown trout, it would be interesting to see what the preyfish are doing there. So if you, and also I should note that there's a statewide objective for mercury and preyfish. So that is data that can be used for water quality assessment as well. So Wes, if we were wanting to do more sampling here to get an advisory, what would we do?
Yeah, so we'd want to, I can't quite see it closer. I'm trying to see how many individuals there are. So we would want 9 individuals from each species. So rainbow trout, brown trout, and then some other species we could find there. And then we'd want to look at the size to figure out how many locations we need.
Yeah, it's a small lake. I think I had that in the slides. It's in the
It was.
small category.
So yeah, 9 individuals with 3 species. That would be sufficient for us, enough data for us to develop an advisory for.
In
And
our
then,
sample, we would try to try to sample where we think people are fishing, even though it's a small lake. Like, so look, starting at the boat ramp and, and working out from there, if it's, seeing if there's any obvious pattern to where people fish there. But it is a small lake, so you're probably going to get a good representation from wherever you sample.
yeah, and some considerations we might have. I know for brown trout, we've offered, I believe it was brown trout, different advice for different size classes, because we saw where above a certain length, the fish started accumulating more mercury. So we would use a certain size cutoff. So we would have, 2 sets of advice essentially.
Yeah. And then just showing the functionality of the portal. So looking at the safe eating guidelines, there's no advisory for this water body, so you get the statewide advice. the general advice for lakes statewide. And then for nearby lakes, well, now it's on, well, it's just showing brown trout. But actually, this is interesting given what I was saying earlier, that sometimes, like it was very interesting in 2007, we found pretty high levels of mercury in Hetch Hetchy Reservoir in brown trout. So that was one of the higher values that we've seen in the Sierra, but suggesting that that's really a resident population that's, well, A, it's a resident population, and B, that there's a lot of mercury in that food chain.
Yeah, Sherry?
Related to the use of this site. In particular, we know that, I'm sorry, I'm having the background.
How about now? Oh, no, that I muted all of you. Hold on. Sherry, we can't hear you.
Okay, there's the known impaired water list, the 303D list that people can Google. I'm going to pop it in here.
See if that's
useful. But the website that you are showing right now, what I remember being useful for it is that it didn't have to have enough of the species to make it eligible for a fish consumption advisory, like the 9 of the same species from the same location. But this what you're showing us here, is it still the same where you can you can go in and see how many, for example, species were taken from a location, and then if that is an area of most interest to tribes, they could go in and then complete that data set, and that would make them be prepared to maybe give information to a WEHA for a future advisory kind of a thing. I'm just thinking about how this might be useful. Yeah.
Yeah, this website shows all data that are available, whether there's an advisory or not, or whether it's listed or not. It just shows all the data. It's mainly the swamp data, but the monitoring by swamp has been pretty extensive since 2007, and it's got some other data sets included as well. But it shows whatever's available for each location.
Yeah, and like you mentioned, Sherry, sometimes filling those data gaps are really useful because it might just be a few samples or a few individuals.
Yeah, and this this rainbow trout sample was, I'm pretty sure it was 5 fish of legal size. So, we would need 4 more rainbow trout and then 2 other species, as Wes was saying, for the minimum for an advisory.
And Jay, I guess that data for brown trout was from TSMP.
So that's just older, that, some of the older data hasn't made it into this portal yet.
Yeah.
So the portal only includes data through 2017. And I hate to do this, but I really want to respect people's time, and we've already gone over the 3 hours that we allocated. But that means more conversations like this are needed, and we will find ways to make that happen. So real quickly, let me share my screen. Just
While you're doing that, I have a couple closing thoughts.
Sure. Make them quick.
Yeah, these are short. We've given you a lot to think about, but hopefully this helps outline the steps that you need to go through to design a monitoring program, whether, no matter what species you're thinking of. I strongly recommend that you all get to know swamp, and at least get on the email list so you know what's on the agendas for the Safe to Eat work group. And if you can get involved in the process, you can let us know what your needs are. And like I said earlier, there's pretty good chance that we'll try to meet your needs if that's at all possible. So, we may have presentations like on plant monitoring, like we were talking about. So, just encourage you to follow what we're doing in the Safe to Eat work group.
Thanks, Jay. So y'all it's February 20th. We're wrapping today's training up. I'm going to shoot to have this recording and the slides sent to your emails directly, and then also posted on the training series webpage by the end of this week. The next training, as Autumn mentioned earlier, is going to be on sample collection protocols and processing. So how our teams do what they do in the field. That'll be on March 19th. And then we'll talk about CDIN and WQX and quality assurance and data goodness in September. So as Jay mentioned, you know, shameless plug, not so shameless plug, we want to partner with y'all, whatever that looks like for you, if that makes sense for you. If you just want to kind of have a one-on-one conversation with the SWAMP program, myself, we can invite others as at your request. There's a link to this tribal engagement interest form. All that's asking is who should be on the call, when a good time is, and what you want to talk about. And then I will work to set that up. If you're interested in listening into the stew, joining the email list, there's links to that there, and as well as our meetings page. And thank you on behalf of our training instruction team. Thanks for joining today, and thanks for staying a little bit over time. So thanks, y'all. And
one more thought. If you do want advice, you know, we're not getting requests for advice. You know, I don't want to get overwhelmed by them, but at this point, we're not getting requests for advice. So we can take some requests for advice. So if you're starting a program and you do want some, advice, feel free to send me an email, and I'll do what I can.
Yeah, to any of us, and we can connect. So thanks, y'all. Have a good afternoon, and we'll see you next time. Bye, everyone.
Thanks everyone. Thanks, Anna.